In the next 7 minutes, you are going to make a program that recognizes when this keypad is pressed and sends the value over the serial bus. Hi, my name is Jeremy, and welcome to the 11th tutorial in a series of videos aimed to teach the basics of using an Arduino microcontroller so that you may compete in this semester's Solid State Circuit Society Arduino contest. More information available in the link below. If you have not already, check out our previous videos as this one will build on their material. A keypad is similar to a keyboard in the sense that it is a grouping of push buttons that can be read by our microcontroller. My keypad has 16 buttons. Recall from tutorial 2, a typical push button sensing circuit places the push button in series with a resistor, where the top is connected to 5 volts, the bottom to ground, and the middle node connected to one of the Arduino's digital input ports. When the button is pressed, the middle node is pulled up from 0 to 5 volts, and the change is read by the digital input. However, with this methodology, our keypad would require 18 ports, 16 sensing wires, plus a power and ground connection. Unfortunately, our Arduino Uno only has 14 digital ports and thus cannot accommodate so many buttons. However, thanks to clever engineering, this keypad only requires 8 ports. So how does it work? If we remove the cover, we see that the buttons are arranged in a grid. The first 4 ports are connected to the 4 row lines. These are used as inputs from the Arduino. The last 4 ports are connected to the 4 column lines. These are used as outputs to the Arduino. By default, the rows and column lines are not connected to one another. Under normal operation, the Arduino sets all 4 row lines to 5 volts. Now, say one of the buttons is pressed, shown by the red dot. Doing so connects the corresponding row and column, in our case, row 2 and column 1. The moment this occurs, the corresponding column line will be pulled high. This is sensed by the Arduino, notifying it of the key press. However, it is still unaware of exactly which button was pressed. So, to locate the button, one at a time, the Arduino sets each row line high. Then, it looks to see whether any of the column lines are pulled high. If not, it continues to the next row. Finally, once it reaches the row with the pressed button, the corresponding column lights up. As such, it concludes that the pressed button is indeed at row 2 and column 1. And so, using a lookup table, it determines that this button corresponds to number 8. Let us build a circuit that senses a button press and sends the value to our computer using the serial bus. Remember to disconnect your Arduino to avoid damaging any components. Then, hook up your keypad as shown. I will arbitrarily use the digital ports 2 through 5 for the column lines and 6 through 9 for the row lines. Next, let's write the code. Today we will make use of the keypad library. To do so, we must download it from the built-in Arduino repository. Go to Sketch, Include Library, Manage Libraries, or press on the book on the left side of your screen. This repository is a super useful resource filled with hundreds of libraries made by the community. Now, there are many keypad libraries to choose from. Today, I will be using the one created by Mark Stanley and Alexander Bervig. In the search bar, type keypad mark and then press on the install button. Once done, at the top of your code, include the library with #include keypad.h. Then, specify the number of rows and columns corresponding to your keypad, in my case 4 and 4. Next, create a two-dimensional array of characters that will be used as a lookup table to determine the corresponding keypad value. Type char key array rows calls, and in the brackets add the button labels corresponding to your keypad. In my case, it looks like this. Then specify the row and column connections, again as an array. Type byte row ports rows, followed by your row connections, and byte call ports calls, followed by your column connections. Initialize your keypad with keypad myKeypad equals keypad make key map key array row ports call ports rows calls. In the setup function, initialize the serial link with serial.begin9600. Then, in the loop function, read the keypad with char val equals myKeypad.getKey. Finally, if a button is pressed, send it over the serial bus. Type if val and in the brackets serial.println val, and you're done. Plug in your Arduino, upload the program, and open the serial monitor. If successful, whenever you press one of the buttons, the corresponding value should appear in the serial monitor. If so, then congratulations! Feel free to play around with the keypad. I challenge you to make a safe. Create a program that waits for the correct password and then turns a servo to unlock the door. Join us next video when we will learn to use light sensors.